Welcome to the Defense and Aerospace Report. I'm Vago Muradian at Boeing's Integration Center in Everett, Washington, where we have the honor of being the first American reporters in this facility to see the KC-46A Pegasus tanker as it's being integrated for the United States Air Force. In full disclosure, Boeing is one of our sponsors, and I have with us Mike Hafer, who is a retired United States Air Force colonel with 26 years of service, who flew the KC-10, C-130, and a whole bunch of other airplanes, and some special mission aircraft, including at the 89th Wing outside Washington, D.C., before you got caught in the gravity of the Pentagon and you could not escape again.
Not escape.
And
but proud to serve.
Exactly. And you're now the Global Business Development or Sales and Marketing Chief for this program. Sir, thanks very much. We had a spectacular tour of these aircraft, including the very first airplane that's going to be delivered to the United States Air Force, the first production version of the aircraft that's going to be delivered. Walk us through where this program is right now. Obviously, the down select decision between very hard-fought two sets of competitions, three if you include the lease that you guys ultimately won in 2011. Bring us up to speed on where the program is today.
You bet, Vago, and thanks for coming out. We really appreciate you taking the time to come out and see the program here.
It was an honor on our part. To be honest, as an airplane guy, this was a real honor.
Good. So right now, where we're at is we have 4 test airplanes that are out there flying. Those are EMD aircraft that they're up and doing flight tests. To that, we just recently added our first low-rate production airplane, LRIP 1-1 or Boeing 1-1 as we refer to it. And back over to the right-hand side, you're actually looking at LRIP 1-2. So that one should be joining our flight test program here shortly into the early of next year. So basically we're into the flight test portion of the development of the program. It's proceeding along very well, and we continue to expand that program as we go through. Now, production-wise, we've recently landed 2 LRIP contracts with the United States Air Force. So the first LRIP contract is for 7 airplanes. The second one follows for 12 aircraft. So those are on contract, and we're building those as they begin to develop. On top of that, basically, then we've been building airplanes for quite a while now. We started that back in 2015, where we've actually gone into production. So I believe we have the current numbers about 22 airplanes in line in some state of production. So we actually have 5 flying, the numbers that you see out here, plus the additional aircraft in production of the 22. And then it even goes deeper than that. Boeing has a lot of confidence in this program. We've done a lot of the long, deep buy on the supplies. And that's taken us probably out to 40-some airplanes. Then we had to lead turn and buy those long lead items.
Where are we on the flight test program? Because you're about 50% through, is my understanding right now.
51% exactly today.
And what are some of the things that you guys have already covered, and what are some things that you still have to cover in that part of the program?
Okay, so it is a developmental program, right? So this is a brand new conversion, taking the old 767 and making a KC-46 out of it, and then we had to integrate a lot of military avionics and hardware that go in on top of it. 51% complete through flight test. There's approximately 28,000 flight test items that need to be checked off. And of course, the first major milestone was milestone C. We had to prove baseline capability. And that was things from being able to show the compatibility with chem bio gear, that the air crews could get in and out and operate around, the maintainers operate around the airplane with chem bio, K-loaders go up. But what we really like to put out there is its capability as a tanker. So we actually did air refueling with the F-16, C-17, A-10, AV-8B, and then also refueled and took fuel on from a KC-10. So those are the major steps that kind of go on that. Now, additionally, the Air Force is smart in the way it acquired this and wrote up the contract. It wanted to maintain full FAA certification. So that means that if we maintain full FAA certification, anytime this airplane is out in the system and needs a spare part, it can swap that part out with its commercial partners that are out there, or just pull that part right off a commercial shelf so that it can keep moving right through the system, no matter where they're at in the world. So we have 2 types of certification. Then we have the supplemental type certification, and then we also have the amended type certification, which is actually the KC-46 type certification from the FAA. So we're working through most of the STC, the supplemental type certification, and we're through the majority of that right now, and then beginning to tick off a lot of the military type certification items.
The Italians and the Japanese had this airplane in inventory, different slightly different model and version than this one, obviously, different set of specifications. But the Italian aircraft, for example, used to have a wing flutter issue that was a little bit of a challenge that was being worked. As you're going through this developmental program, are you seeing any aerodynamic or structural issues that are giving you any sort of speed limitation or any other challenge on the airplane?
Well, I'll point out first of all that they are completely two different airplanes. There was the KC-767, of which we built 4 for the Japanese and 4 for the Italians, and this is the KC-46. They share the same lineage, completely different airplanes on the inside. But now to answer your question directly, no. This has been a very stable development program as far as the wing air refueling pods, the centerline drogue system, and the boom itself. We're not seeing any of those issues that would have may have arisen from the previous airplanes.
And obviously this airplane has been costly for Boeing. It is the way the program is being done on a fixed price basis puts all the onus on you guys to be able to deliver airplanes at a cost for the Air Force. And it has been a little bit costly. From the standpoint of challenges, where are you on resolving those challenges? Is all of that in your past? Do you look at clean sailing forward, or are there still things that you guys are trying to work?
I'll go back to my initial statement, it is a developmental program. And when you flight test, you don't know exactly what you're going to discover. I mean, we took a lot of investment up front and we built 5 labs. So we built a systems integration lab, which actually puts together the civil avionics together with the military avionics, which blended them all together. We built the wet fuels lab so that we can test and evaluate the pumping of the fuel all the way around. Built a lighting camera lab so we can test out the covert lighting, the daylight lighting, and all the cameras that went with that. We reduced a lot of that risk and actually saved a lot of flight time and development time by doing that testing on the ground. But as in any other type of development program, we did run into some hiccups. We are, like we said before, 51% through flight test. We think we have most of the major hiccups back behind us. It did cost us a little bit. I should say, there were costs involved, but we're moving out very smartly now. We're getting through what we just don't know what we may discover as we get down the road.
Are the models, right, because flight testing is also the validation of the model that you had, is the flight testing validating your models?
Yes, it is.
Well, that's good news.
Yeah, absolutely. Yeah. There are no major surprises in the operation or the flight characteristics of the aircraft itself or of the air refueling systems.
Let me take you to the differences between this airplane. Walk us through from the birth of the airplane. Obviously, they come on the assembly line in the same facility, the world's largest building by volume, where the 747, 777, 787, and 767 are all being produced in that facility just across the way. When this airplane is born, how different is it from a 767 freighter, which is its original, and what are the modifications you're doing there, and what are the modifications you're doing here?
Okay, great question. I want to point out right at the heart, from its birth, this is a 767, in its DNA, and it's a very reliable airplane, 98.6 or better mission capability rate, departure reliability rate. FedEx bought this airplane because when it has to be delivered overnight, they put it on a 767. And that's exactly what the United States Air Force is going to get, that or better. When the country relies upon this military capability, this airplane's going to go. So you take that phenomenal departure reliability rate, mission capability rate, and you put it through the same line. But as it goes down through the line, obviously they're going to have a lot of military avionics and military system that kind of goes into the development of the KC-46. Differences really kind of come out to, I need to be able to put some of the defensive systems on, the mods, the panels, the bumps, that'll accommodate all that. So those are panels that are kind of done up at the main factory, as well as the wiring that goes with that. This airplane has about twice the wire bundles of the 767 the KC-46 carries with it. But when it's built up in the main factory, it's what we call a provision freighter. So it has all the plumbing, all the accoutrements, all the Group B equipment mods that come through the line. It is then towed down here, where we finish it out and we put on the military hardware. The military hardware being the radar warning system, the large aircraft IR countermeasures, the boom, the CDS, those type of equipment mods. So that's really what kind of goes on here. Is we finish it out, we take that 767-2C and turn it into a combat-ready KC-46.
What are some of the capabilities of this jet? I mean, when we were talking and going through it, there were a whole bunch of features on the jet. you guys hired a crew chief to be part of the team for the serviceability of the airplane, to make sure that it has a 1-hour ground turnaround time, which is probably better than any other tanker that we have in the inventory right now. Having covered AMC a long time ago, I remember a lot of time on KC-135s and KC-10s, more time on 135s. But talk to us about some of the things on the airplane that you guys are most proud of, that you think is going to deliver and make the lives of airmen, whether they're up in the cockpit or whether they're on the flight line, easier.
Yeah, exactly. And as you mentioned, one of the smartest things we did is we brought in an ex-Air Force crew chief and hired him to work side by side with the engineers and design that airplane from the ground up, and changed a lot of the systems so that it was easier to maintain, easier access to get at throughout the entire lifespan of the airplane. It was things like on top of the in the air refueling pod on the top, there's a hydraulic accumulator. Traditionally, the crew chief had to climb onto the top of the airplane to read that gauge. We've now located it down to the nose wheel so that the crew chief can stand on the ground and check that hydraulic accumulator directly from there. You can fire up the APU right from the nose wheel area, so you can get the aircraft warmed up, get electrics and power and pneumatics on the airplane before you go through.
And that is for the nuclear alert mission, so that guys can hit that switch and get up to the cockpit and take off.
That's one of the great benefits, or when it's really designed. But even for day-to-day operations, when you come out, fire that thing, fire the APU up from the ground. But then it does give you less than a 10-minute response time to get the airplane airborne in case of a national emergency.
Talk to us a little bit about, because in the back of the airplane is where the auxiliary power unit, the APU, is. And historically, it's a very labor-intensive operation for the crew to check that, open up the clamshell doors in the back. Walk us through what you guys have done over there to make life a little bit easier for folks.
Exactly. And that was one of the other things that the crew chief really kind of recommended was traditionally you'd have to get on a ladder to get up to check out the APU, but to open up those clamshell doors in the back, you had to bring out a special tool to bring the boom down. It required a handful of people to lower the boom and then climb up and take a look at the APU that's up there. We've decided to bypass that. So why do you have to do that? If we built doors within inside of the clamshell doors, inspection doors. So now you can just basically go up there with a ladder, 2-person operation, get up there, inspect the APU before flight, and then come back down without ever having to lower that door. AMC projects that it'll save at least 100,000 man-hours over the first initial career of the airplane, over 30 years.
And your guys have 2 refueling ports that are under the wing. What are some of the, what are the advantages, and what were you trying to achieve with that?
Yeah, exactly. So it's almost a misnomer. We call them single point refueling, but you can refuel the entire airplane from one single point, but we actually have 2 of them. And they allows the ground handling personnel to refuel the airplane while standing on the ground, while on terra firma. Don't have to get ladders to get up into the wings or over top of the wings. Stands right on the ground, has access to the fuel panel. Person standing there could just hook up the fuel hose, refuel the entire airplane. If there are 2 trucks or 2 hoses, hook them up, run it simultaneously. Again, safer operations, allows for quicker refueling the airplane, quicker turn time. I do everything from the ground, don't need all that support equipment. Really helps you out in the deployed environment. Now I don't need fuel trucks, fuel ladder trucks that kind of come in and do the refueling.
You mentioned that this is a combat aircraft. This airplane also has a unique set of protecting features for the crew, not only in the air, but also on the ground. Tell us as much as you can tell us about those capabilities.
Extensive suite of defensive systems on board the airplane. It's designed to operate in a medium threat environment. And that goes all the way from, as we talked about just briefly a while ago, the nuclear mission, so it's EMP hardened, as well as then it has flight deck armor protecting the crew in around the area, so it protects from basic ballistics on the ground. On top of that, it has great situational awareness. It's equipped with the TSAS Link 16, so it can communicate 5th-gen fighter aircraft as well as other aircraft in the area. As well as that, it then ties in radar warning systems with LARICM on top of those systems. So you have great situational awareness. You know what's going on in the fight around you. You're fed and can transfer that information out to other components that's with you.
The airplane also has obviously 4 refueling stations, right? It has the 2 warp pods, the wing refueling pods, which are about 2,000 pounds each, made by your partner Cobham. You have the centerline probe and droge, right, that you have there, and then you also have the boom, which is a derivative of the KC-10 boom. Talk to us a little bit about those outboard pylons and how you guys can take those off and actually put other things on it. What are some of the features that you have to allow that, and what are some of the other capabilities the airplane can carry in the future?
Yeah, okay, so the wing air refueling pods, they are removable, and the primary purpose for being out there is to provide hose and drogue refueling, as you mentioned, 400 gallons per minute. They are equipped with electricity and an Ethernet cable, so that should the Air Force in the future decide they want to put some type of other instrumentation or some other system on there, it's already enabled. So we have the plan form of the wing air refueling pod already approved, FAA certified, and so if the Air Force should decide, or any of the other Department of Defense customers, that they'd like to put some other weapon system or sensor on there, it's already equipped and ready to go with that.
Let's talk a little bit about the cargo capability of the airplane as well. You guys have that big side door. Makes if you were looking at it, it looks a lot like a 135 from profile. But walk us through the cargo capability of the airplane. How many pallets you guys can carry, and how much cargo load?
Yeah. So exactly. Again, I go back to at its heart, it is a 767 freighter. And so it's kind of designed with that door inside there. And so if you just wanted to go with a pure cargo configuration, you could fit 18 463L NATO standard pallets inside. They'd have to be conformal and up to 65,000 pounds on the cargo floor. It is a multi-role aircraft, though, so you can do passengers, you can do air medical evacuation, you can do cargo, or any combination of those three thereupon. It's designed to operate with the palletized seating. So its standard configuration that the Air Force wants to go with is 54 passengers. It gives you 3 additional pallets for some baggage, cargo to bring on hand, as well as a galley lab then to be able to support those passengers, make them comfortable while in flight. Additionally, then we have the air medical stanchions that are always on board. There's 6 on board, or expandable up to 24 of the litter stations plus 32 ambulatory, give you 56 patients to carry in an air medical evacuation role.
And you also have a bunch of crew features, right? Because it was good to see the 3 racks and actually a full proper commercial head in it.
That's exactly correct. You got to take care of the crew. Crew's got to be comfortable and be able to fly there. As well as within the air refueling station, something I noticed that you noticed was that there was the cup holder there for the air refueling operators.
That's right. Yes, life has changed, so you no longer have to pop rivet a ring to the bulkhead in order to be able to hold something. Let me ask you about the global competitive dynamic. Obviously, your job is to manage the sale of these airplanes globally. Obviously, the United States Air Force, it's a big blue ribbon seal of approval, but Airbus has been very, very successful with the A330, UK, Emirates. There are a lot of countries around the world. The Australians are operating that airplane. They're very, very happy with it. What are the features that you think your airplane is going to bring to the market at the right price point that's going to attract business? How many of these airplanes do you expect to sell around the world?
So I'll kind of go back and address your first part of the question there is, where, Airbus has been successful. We just now finally have metal that's up and flying. Previously, a lot of those competitions, we had the design, but we just didn't have an airplane prototype. Airbus had that out there. And of course, it always comes down to what are the individual countries' requirements? What do they need, and what are they looking for? I will tell you from here on out, if you're looking for a combat tanker, the KC-46 is the clear, unequivocal leader in that realm. All the things we've already kind of pointed out. And we see a lot of interest in other countries starting to come on. Now that we're actually up and flying, there's a wellspring of interest in this airplane. Japanese have already down-selected us, and we're working through contract negotiations. Expect to have that out early next year, as well as several other countries out there. There was a European study on Odyssey Dawn that said that there's a European demand for about 200 KC-135 equivalents out there. I don't know that there's that much. I don't think the defense budgets are there, Mike Hafer's opinion only, to support that, but there's definitely a need for air refueling tankers and capability.
How large do you put the size of the market? How many airplanes, say, over how long a period, say 20 years, how many airplanes do you think you can, how large is the global market, and how many of those do you think you're going to get? Let me put it that way.
Your time span's much longer than mine. I'm going to keep it inside of 10 years, and I'm estimating somewhere around 35 tankers probably within the next 5 to 10 years that might be able to be won.
And you guys think you're going to get the lion's share of that?
I think we are going to.
And let me ask you one other question. Lockheed is talking about developing a tanker as well. Normally this is seen as a binary race between you guys and Airbus. How does the entry, are you guys looking at Lockheed as being a significant challenger in this?
Well, I guess what I'm looking at is it always goes back to what are the requirements. And I believe you're talking about the KC-Z competition that AMC started talking about and the Air Force has started talking about. In our conversations during several meetings is the Air Force really wants a revolutionary product, needs to redefine how tanker ops are done in an anti-access area denial type theater, near contested airspace, maybe in contested airspace, and with or without pilots or boom operators on board, yet to be determined. We are very aggressively pursuing all those options. How do we get into that fight? We look for that competition. Our development, our Phantom Works team has been working on that for several years, for over a decade, as we begin to develop different plan forms that we look to that KC-Z competition.
And are any of them larger airplanes, say a 777 class airplane or a 787 that could give a greater offload capability than the jet we have behind us?
That, again, I'd have to go back to what are the user's requirements. They have not specified what the offload requirements are, so that would really kind of base the size of the platform that we would use. So right now there's no game plan to use a KC-777 or a KC-747.
Let me ask you one other thing. You mentioned, and you were very, very proud and showed us when we were walking around the airplane about the infrared lighting system that goes all around the airplane. Last question, walk us through that, what you guys are thinking, and why you guys think that's such a significant innovation.
That again was an Air Force requirement. That was it had to be on board the airplane to be able to do daytime and covert operations. It's a very unique capability. It allows us to start, taxi, take off, fly the air refueling mission, and then land without ever putting out a single photon of visible spectrum of the light. Air Force requirement demanded to be able to do that. We've built to that specification to be able to do that. As a matter of fact, we can proudly announce, and we'll probably have a further article coming out here in the near future. We've had the first nighttime air refueling contact using night vision devices solely. So it was the first time ever that the United States Air Force has flown up behind a tanker, taken the plug, received fuel, and have done it all with covert lighting.
And the first time that somebody did it without lying on their belly or sitting in a chair in the back of the airplane.
That is correct, done from the air refueling operator station just after the flight deck.
Mike, thanks very much. Best of luck on the program, and thanks so much for allowing us to come and see the airplane.
Vago, it was our pleasure, and we look forward to showing you more about it in the years to come.